Integration is reverse of differentiation, and this is the sign of integration. You can take it as operator which follows certain rules. Integral of 1 with respect to x is x. C is arbitrary constant. Since integration is reverse of differentiation, and in differentiation a constant number become 0. So while performing integration, we write arbitrary constant c as symbolic, and so in rule number 1, integral of 1 is x. In rule number 2, if you have x raised to the power n, then on integration you will add 1 to this power, and the same power will come in the denominator, plus arbitrary constant c. In rule number 3, a is multiplying with x power n, so in integration this a will remain out, and you will take integral of x power n. Same way you will add 1 to this power, and the same power will come in the denominator, plus arbitrary constant c. In rule number 4, you have a linear bracket, and you can notice that x is appearing only in one term, and power of x is 1. It's very important. You have a linear bracket power n. On integration, you will copy the bracket. You will add 1 to this power. The same thing will come in the denominator, and you multiply it by the coefficient of x, which is a, plus arbitrary constant c. So c is arbitrary constant. The following examples are useful, and I have to integrate 3x squared plus 2x plus 3 with respect to x. So what I do, this step, let me point out first, is not necessary. And since I want to illustrate my example clearly, so I'm showing this step. So when you come to the first term, the 3 will come out since it's a constant number, and you will take integral of x squared. Then you come to the second term. If you have plus sign, it will remain as it is, and you will write 2 outside and take integral of x. For a constant number, you can show this step, that take 3 out and show integral of 1 with respect to x. Then you apply integration rule. This 3 remain as it is. For x raised to the power 2, you will add 1 to this power, and same thing will come in the denominator. For x power 1, you will add 1 to this power, and again the same thing will come in the denominator. Integral of 1 is x. Now you can simplify it. X will be x cube over 3 multiplied by 3, 2x squared over 2 plus 3x plus c. 2 get cancelled out, 3 get cancelled out, and finally you get x cubed plus x squared plus 3x plus c as your final answer. Move on to another example, second example. You have to integrate square root 3x plus 1 dx. So first of all, you will simplify square root. You will write square root as raised to the power half, and then you integrate following the bracket rule. So you will copy the bracket and you will add 1 to the power, and the same power will come in the denominator. Then according to this rule, you will multiply by the coefficient of 3 this way. Now simplification is required. 3x plus 1 raised to the power 3 over 2. Same 3 over 2 will come in the denominator, multiply by this 3. You can simplify the denominator. This will become 9 over 2. And you can flip 9 over 2 as 2 over 9. 3x plus 1 raised to the power 3 over 2 plus c. C is a formality, arbitrary constant. So this is your final answer. Now I will show you a past year paper question as an example. This came in November 2013. Question number 3, part 2. First of all, you have to integrate 2 over square root 5x minus 6. You can simplify it. You can write 5x minus 6 raised to the power minus half. Or if you want me to do one more step for you people, you can write 5x minus 6 raised to the power half in the denominator. Then you can do this step taking half in the numerator. This will become minus half. You can take 2 out of the integral sign. And this will become minus half plus 1 is 1 over 2. Same 1 over 2 will come in the denominator. Multiply by the coefficient of x, which is 5, plus c. You can write it as 5 over 2 in the denominator become 2 over 5. 5x minus 6 raised to the power half plus c. This will become 4 over 5, 5x minus 6, 1 over 2 plus c. Now if you look at the question, there is a definite integral as well, and if you integrate with this definite integral, you can use the result which you have already obtained in the first part and apply the limit. So this is the integral, and when you are finding definite integral is the one in which limits are given to you. Then there is no need to write arbitrary constant c. So you can apply the limit 2 to 3. You will write 3 in place of x, (15 minus 6 raised to the power half). First of all, you will take this upper limit in place of x. Then you will write minus lower limit in place of x. This is the lower limit. So 5 into 2 will become 10. And this will be 9 raised to the power half. You can use your calculator. 9 raised to the power half is 3. 4 raised to the power half is 2. And this will be 12 over 5, 8 over 5, and this will become 4 over 5. And this is the answer for the definite integral. There is one more example from past year paper. This question came in November 2012, variant 1-1, question number 2. A curve is such that dy by dx is minus 8 over x cube minus 1, and the point 24 lies on the curve. Find the equation of the curve. Your dy by dx is minus 8. Let me simplify it and write x power minus 3. So this is your dy by dx. You have to find, first of all, the equation of the curve. So you have to get rid of d over dx. Since integration is reverse of differentiation, so clearly you have to integrate both sides. But before that, you have to do separation of variable. This means you have to take dx to the side of x, that is your right hand side, and then you will write integral sign as Integration is reverse of differentiation. Now in this case, this integral sign will cancel out this derivative and you get y. And if simplified further, x power minus 3 can be integrated as minus 3 plus 1 minus 2, and the same minus 2 will come in the denominator. Integral of 1 is x, and there is an arbitrary constant c. And you can simplify it. This will become 4 over x square minus x plus c. Note that 2, 4 is the point given on the curve. So you will use this point to get the value of c. In place of y, you will write 4. In place of x, you will write 2. 2 square is 4. And this will be and if you separate c, 4 plus 1, and c will be 5. So your final equation of the curve is four over x squared minus x plus 5 is your final answer. Now we come to application of integration. So first topic is area and volume along x-axis. Suppose I have a curve y equals to fx, and I'm integrating it for the limits a and b on x-axis. Then on integrating the curve for the limit a and b, I get the area between the curve and x-axis. That is the yellow highlighted area. So if you have to find area, you can use integration, and you have to choose some proper limits. Like in this, the limits are a and b. So you simply integrate and you get the area. This is the yellow shaded area, highlighted area. Now if you rotate this yellow highlighted area 360 degrees about the x-axis, you will get a solid. And volume of that solid is pi y squared dx for the same limit a and b. So this is how you find volume using integration. Likewise, you can find area and volume along y-axis. And if suppose you are provided with y equals to fx, then you have to rearrange it this way. Write x as a subject, x as function of y. So your curve is x equals to function of y for y-axis, and the limits are on y-axis c and d. And if you integrate for the limit c and d on y-axis, you get the blue highlighted area, that is the area between the curve and y-axis. So This is the area, blue highlighted area. And if you rotate this blue highlighted area 360 degrees about y-axis, you get a solid, and volume of that solid is this. You have to keep this x squared and dy in your mind while doing such questions. I can show you an example from past year paper. It came in June 2012, variant 1-2, question number 1. The diagram shows the region enclosed by the curve y equals to 6 over 2x minus 3, the x-axis, and the line x equals to 2 and x equals to 3. Find in terms of pi the volume obtained when this region is rotated through 360 degree about the x-axis. I have highlighted this region, required region, with this yellow highlighter. This is the equation of the curve given to you, and you have to find the volume by rotating this yellow shaded area 360 degree about x-axis. So first of all, you have to note the formula for x-axis. This is for volume, and six over 2x minus 3 whole square dx. Now you will simplify it. It is pi, 6 square is 36, 2x minus 3 square dx. You can take 36 out and simplify this thing this way. Now this is a convenient form, and you can integrate it. 36 pi remain as it is. Integral of this linear bracket is 2x minus 3 minus 2 plus 1 is minus 1. Same power will come in the denominator, multiply by the coefficient of x, which is 2. And you have to put the limit 2 to 3 and you will write 2 to 3 over here as well. There is no need to write arbitrary constant c because limits are given. So this will be you can take this minus 2 out like this, and you are left with 2x minus 3. This will become minus 18 pi, and here you can apply the upper limit first in place of x. So 2 into 3 will become 6, upper limit minus lower limit. 2 into 2 is 4. And if you simplify it, you get minus 2 over 3. And 12 pi is your final answer. You can leave it in terms of pi. So this is your final answer.